Today we're going to discuss the basic marine electrical engineering. So, sa marine electrical engineering, we have some definitions. Number one definition is the current. Yung current, it is the flow of electric charges per unit of time or it's the flow rate. Ang unit niya ay amperes. So, pag nakita nyo, kung ilang amperahe, yun yung current. Yung current, kapag analogy mo sa water, ito yung flow rate, ito yung tubig, amount ng water na nagflow doon sa piping. Tapos we have the electromotive force. This is the potential difference or yung electric pressure na nagda-drive doon sa flow of charges, doon sa current. So, ito yung voltahe, yung volts, measured in volts. Tapos, we have the resistance. Ito yung pumipigil doon sa flow ng current. Kumbaga sa piping, ito yung friction. Ang unit ng resistance ay ohms. Ang conductor, tinatawag na conductor ang isang material kapag meron siyang mababang resistance para yung current mag-flow. For example, silver, copper, iron. Yung mga conductors na to, ito yung ginagamit sa mga wires. Mapapansin natin yung mga wire natin, mga cable, gawa siya sa copper. Tapos, yung ibang conducting material like iron, they have the little resistance. Tapos, yung current, magpo-flow yun. Kaya ginagamit sa mga wires ay copper. Yung silver naman, good conductor siya ng electricity. Kaya lang, mahal siya. Kaya copper yung ginagamit. And kung may conductor, we also have the insulator. Ito yung kabaliktaran ng conductor. Ito yung katulad ng plastic, ng kahoy. For safety purposes, ginagamit yung insulator. Meron tayong direct current. Dalawa kasi yun, merong alternating current at direct current. Yung direct current, ito yung current flow niya ay, kung tawagin ay unidirectional or isang one single line. Example nito, yung mga DC ay yung mga batteries natin sa bahay, yung makikita natin. Yung Ohm's law, applicable ito sa direct current in which a current in a circuit is directly proportional to the applied voltage. Yan, ito yung Ohm's law, and inversely proportional to the circuit resistance. So, ibig niyan sabihin, yung Ohm's law, kapag tumataas yung voltahe, tataas din yung current. Pero kapag tumaas yung resistance, bababa si current flow. Kasi yung resistance nga yung pumipigil dun sa current flow. Then we have another formula, yung power equals to amperes times the voltage and equal to yung square ng current times the resistance equals to watts. Ohm's law din siya nang galing. We have the generators. Itong generators sa barko, this is the heart of the ship. So bakit ito yung puso? Kapag ito ay namatay, so titigil yung pagtakbo ng barko. Kasi yung generator, siya yung nagbibigay ng electricity dun sa mga machinery sa barko para umandar yung main propulsion natin, which is yung main engine. So this generator is alternating current. So this is a machine used to convert mechanical energy into electrical energy. Ang nagdadrive dito sa mga generator ay yung diesel engine. Kumbaga, sa 4-stroke diesel engine, ito yung nagdadrive dun sa alternator natin. Kapag drive siya or naka-directly couple siya dun sa alternator natin, it induce a voltage. Kasi yung alternator natin comprised of comprised of commutator tapos yung stator. Yung magnetic field, ikakat niya yun, tapos makapag-induce siya ng voltahe, which is, it is the elements of the Faraday's law. Generator parts, we have the generator parts, the prime mover. The prime mover is basically the diesel engine. Makikita niyo yan sa barko. We have the armature windings. Ito yung conductor in which the output voltage is induced. Field windings. Ang ginagamit sa barko, yung field windings, ito yung may electromagnetic field pero nangangailangan siya ng DC power supply. Ito yung magnet. Kasi yung DC power supply sa barko ngayon ang ginagamit mga brushless na mga alternator. So gumagamit ng rectifier. So ang rectifier, it converts alternating current power to direct current power. So itong rectifier, ito yung nagbibigay ng DC power supply. And the DC power supply, it produces electromagnetic field para makapag-produce ng voltage para masunod yung Faraday's law. Yeah, we have the stator, the rotor. So yung field windings nandun na rin sa stator. This stator housing of the generator contains the magnet or the field windings. Ang rotor naman, ito yung dinadrive ng diesel engines natin. Ito yung gumagalaw, umiikot. This inside the stator, moved by a prime mover. This prime mover usually the diesel engine. This contains the conductor or the armature windings. So pag umikot yung rotor, ikakat niya yung magnetic field. So pag kinat niya yung magnetic field, makakapag-induce ng voltage. Tapos, pag nakapag-induce ng voltage, makapag-produce ka na ng electricity. Yan yung Faraday's law. Yan yung principle ng generator. Yan, induction of voltage or the Faraday's law. So, may tatlong bagay na must be present in order to produce the electrical current. We have the magnetic field, the conductor, and the relative motion. This magnetic field, as I explained, ito yung nandun sa stator. Ito yung magnet na pinuproduce ng DC power supply. And the conductor, ito yung sa rotor na it cuts the magnetic field around the stator field. And the relative motion, ito yung rotating movement ng stator ng rotor na dinadrive ng diesel engine. So the conductor must cut the lines of magnetic flux to produce a voltage. Ang direction tsaka yung speed ay important, pero usually sa barko 900 RPM yung speed ng diesel engine. Yan, ito yung electromagnetic induction. So we have the magnet and we have the coil or the conductor. So, halimbawa mayroon tayong voltmeter, yung coil o yung conductor, halimbawa itong magnet na to. Pag itong magnet, umiikot to, tapos meron tayong coil or the conductor. Yung Faraday's law, sinasabi na pag nag-ikot yung magnetic field or the conductor into the magnetic field, makakapag-induce siya ng current. Tapos yung induced current na yun, mayroong electromotive force o potential difference. So, meron tayong voltahe. Pag may voltahe tayo, may kuryente tayo. Just simple as that. So, this is the AC power. So, pag-usapan natin yung alternating current theory. The alternating current is the magnitude and direction of the current flow in an alternating current circuit will change periodically. It's called a cycle. The frequency or the hertz of an AC circuit is the number of cycles per second. Yung hertz, yung unit ng frequency. Yung kabaliktaran ng time. So we have here the alternating current. The current is constantly changing in magnitude and direction. So makikita niyo yung yellow lines or yung yellow graph. So sinusoidal siya. So we have at y-axis we have the current, at x-axis we have the time. So imagine yung yellow line, ito yung current. Tapos yung current sinusoidal siya, mapapansin niyo umaangat siya. Pag-angat niya, positive sa taas. Pagbaba niya, nagiging negative. So over time, makita niyo sinusoidal waves yung mapoproduce niya. Current is a function of time and usually varies as a sine function. So, ibig sabihin, dependent yung current doon sa time. So, this is the simple principle ng revolving field o yung sa generator. From this, we have the DC battery which produces the magnetic field. Or for our example, we have the magnetic field, we have the armature winding. So, pag umikot tong magnetic field, so, meron slip rings, may brushes, tapos makapag-induce siya ng voltage na i-absorb ng DC battery. Pero itong example natin, wala na to sa barko. Sa barko kasi brushless na siya. So, wala nang mga slip rings. Meron lang rectifier. So, yung generator, yung mga terms niya, we have the number of phases. Sa shipboard electrical power natin, usually 3-phase yung ginagamit natin. Mayroon tayong dalawa, single phase at 3-phase. Sa mga makinarya, usually naman malalaki, 3-phase yung ginagamit. Tapos sa mga ilaw, single phase. Ang frequency na ginagamit sa barko ay 60 Hz. Pag electronic naman, 400 Hz or higher. Yung voltage usually na ginagamit sa barko, pag low voltage, 450 volts or 440 volts. Ito yung 3-phase. Pag 440 volts, 3-phase yun. Ang mga appliances or ilaw gumagamit ng 100 volts to 120 volts. Pero merong mga high voltage sa barko kung tawagin. Ito yung may 3.6 kilovolts or 3,600 volts, 6,000 volts, gano'n. Pero usually, 440 volts lang yung iba. Yung power rating, ito yung measured in kilowatts. Ang kilowatts is a unit of power. So most shipboard generators are usually, they are 2,000 to 3,000 kilowatts. Three-phase electrical power. Kung three-phase siya, ibig sabihin may tatlong set siya ng armature winding to produce the three separate outputs. So yung armature windings, they are physically separated 120 degrees from each other. So more power may be generated by a generator of a given size and weight. So pag mas malaki yung generator mo, mas malaki yung power na mapoproduce niya. Yan. Three-phase. Ito yung three-phase na sinasabi. So we have the phase A, phase B, tapos phase C. Pero itong wires to, mga to, wires. So magnetic field. It produces magnetic field. So ito na yung sinusoidal function or sinusoidal graph ng three-phase. May tatlong color tayo, yung color blue, yellow, tsaka pink or magenta. Yan yung tinatawag na three-phase AC power. And we have another electrical appliance aside from the generator. We have the induction motor. Ang induction motor, this drives the most of all the machinery on board the ship. Merong single phase, pero most of the time, three phase siya. If not, most of the time, all of the time, three phase siya. Kasi yung sa single phase na motor, iba ang klase ng motor yon. So, they uses capacitor. But this type of motor, this induction motor, this is very simple and reliable and cheap. So, mapapansin nyo lagi, pag sumakay kayo ng barko, ito yung makikita nyo, induction motor. So, simple lang siya. Ang principle naman niya ay kabaliktaran nung sa generator. Kung merong current na mag-flow, makapag-produce siya ng magnetic field. So pag napag-produce siya ng magnetic field, iikot yung rotor. Kung sa generator, kung pag nag-rotate yung magnetic field, makapag-produce siya ng current, induce ng current. Dito naman, kabaliktaran. Kapag nag-flow yung current, makapag-induce siya ng magnetic field. So, iikot yung rotor. So, this is very ideal for all machinery applications on board the ship. So, halos lahat ng machinery sa barko, katulad ng compressor, ng different kinds of pumps, blowers, induction motor yung ginagamit. Three-phase induction motor. Other than those, we have other electrical devices. We have the batteries, yung dry cell batteries. Ito yung cylindrical zinc container or yung mga simpleng baterya na rin, AA, AAA. And we have the wet cell battery. Ito yung mga lead acid battery. Yung mga Motolite, yung katulad yan, Motolite. Yan yung wet cell. Kapag lead acid battery, ito yung principle niya. So by chemical reaction, we have the lead, yung PB, and we have the sulfuric acid. So by chemical reaction, lead plus lead oxide plus the sulfuric acid, we can produce yung lead sulfate tapos water. So by this chemical reaction, we can produce or induce a voltage. Karamihan sa battery sa barko ginagamit lead acid battery. Yung iba maintenance free, yung iba naman gagamitan ng distilled water para refillan yon. Saka tinetesting yon lagi or weekly yung mga batteries kasi ginagamit siya for emergency. We have also the transformers. Itong transformers, it transforms the voltage into the lower voltage. So, pinapalit niya yung voltahe. So, from higher voltage, it transformed it into the lower voltage. And vice versa. From lower voltage into the higher voltage. Kapag from higher voltage to the lower voltage, ang tawag sa kanya step down transformer kasi pinapababa mo yung voltahe. Ano ba, from 440 volts, ginawa mong 110 volts, yun yung step down. Pero pag 110 volts, tapos ginawa mong 440 volts, pinataas mo, yun yung step up transformer. Yan, ito yung simple transformer. Meron siyang primary winding, tapos meron siyang secondary winding. Itong winding, coil siya, copper coil. Tapos meron tayong core, conductor siya. So, the principle of induction. So, meron siyang magnetic field na mapuproduce. Depende yun sa number of turns. So, I will explain it in other video, yung transformer further. And we have the rectifiers. Itong rectifiers, it uses diodes to convert alternating current into direct current. Ang rectifier, ginagamit siya sa generator para makapag-produce ng DC power supply, para makapag-produce din ng magnetic field. Tapos ginagamit siya sa mga battery charger. Kasi ang battery ay DC. Tapos yung source natin, alternating current. So from alternating current into the direct current, we can use rectifiers. Ang rectifiers gumagamit ng diodes that have small resistance to current flow in one direction only. So para siyang gate or check valve. So ito yung rectifying device output. So ang principle niya ay because mababa yung resistance niya to current flow in one direction. So one direction lang, di pwedeng bumalik. And a very large resistance to current flow in the opposite direction. So ibig sabihin, kapag nag-flow siya in one direction, mababa yung resistance niya. Pero pag bumalik siya, so tataas yung resistance niya. So para siyang check valve nga, unidirectional. And this act as a conductor for half of the cycle and as an insulator for the other half. So kalahating in the cycle, ang rectifier kalahati sa time ay ano siya, conductor. Tapos mapapansin natin dito sa output, kalahati ano siya, insulator. So, sabi nila nakakamatay yung high voltage. Pero ang nakakamatay talaga ay yung current. Kasi ito yung current, ito yung amount ng charge. So, coulombs per time. Ang voltage, ito lang yung pressure. Ang nakakamatay talaga yung current. So, 10 milliamps lang, magkaroon ka na ng severe shock. So, 100 milliamps, nakakamatay talaga. So, imagine 100 milliamps lang, sobrang liit. Yun yung nakakamatay. So, that's all for the basic electrical engineering sa marine electrical engineering. So, in other video, I will discuss further the transformers, rectifiers, generators, and induction motors. So, thank you.